Okay, welcome everyone to It's Raining, It's Pouring. This is a lesson from GreenLearning's Flood Ed program. We're going to be going through a couple of different activities relating to flooding today, and I'm really excited to have you all here, so welcome. My name is Sydney Howlett, and I am the engagement manager with GreenLearning. I'm a former elementary teacher myself, teaching in mostly Southern Ontario, a mix of English and French, actually. And I'm joined today by Andriana, who's also from GreenLearning. She's our program coordinator, and she'll be helping out by dropping some helpful links in the chat. If you have any questions, she'll also be monitoring the chat throughout to help you along with any technical or questions that you have. So feel free to use that. There will be an opportunity to ask questions throughout the workshop. So if you or your students have any questions, I encourage you to put them in the chat and we'll stop throughout to answer those questions. Okay, so we're going to get started. Andriana did drop the student workshop, the student handout in the chat. So if you didn't have a chance to get a copy of that, you can find it there. All right, so what are we going to be learning today? So our learning goals is that by the end of this session, your students will be able to identify different causes of flooding, calculate the area of the permeable, semi-permeable, and non-permeable surfaces of your specific school, and that they can think critically and draw conclusions about the flood risk of your school based on that map. So in order to understand the different types of flooding, I have a quick video that we're going to go through here before we start discussing anything, so we can all have a baseline understanding of what types of flood there can be. So I apologize, this video does have some quiet sound. So if you're having any issues hearing it, Andriana is dropping a link of to the video in the chat. So you're welcome to click on that if the sound is better for you.
The National Weather Service differentiates between 4 different kinds of floods, all unique in their own way. I'm Storm Meteorologist Jason Myers, and in no particular order, here's all 4 and what they mean. Aerial flood. This is a gradual flooding resulting from persistent moderate to heavy rainfall. It's usually a ponding or buildup of water in low-lying areas. River flood. A specific point along a river or creek surpasses its flood stage. Water spills over the river's banks. This can be because of persistent rainfall, snowmelt, and ice jam, or a combination of all 3. Flash flood. These floods occur quickly or in a flash, usually within 6 hours of heavy rain. Small creeks and streams rise first and the fastest. These can also occur if a levee or dam fails. Coastal flood. This occurs during higher than average high tides made worse by heavy rain and onshore winds. These are most common during tropical storm events. No matter what kind of flood it is, they're all dangerous to lives and to property, so avoid them at all costs, and if one is headed your way, take the necessary precautions. Thanks.
Awesome.
The National Weather Service
so there's
between
an example of 4 different types of floods that can occur. Now my question for you is, have you ever experienced flooding at home, at school, or in your community? And this doesn't have to be meters or feet of water. This can be something as simple as ponding. So on the left there, you can see a picture of ponding. So that's when the water really has nowhere to go and it ends up pooling. And sometimes this can only be a few centimeters to a few inches of water. You can also experience flooding inside buildings. So for example, if a pipe bursts in your home or your school, typically in basements, this is very common to have flooding. You may have experienced that as well. So I'm going to give you about 1 minute with your class. I want you to talk about whether or not you've experienced any flooding and where you may have seen that flooding. So I'll give you about 1 minute to do that. And feel free to drop in the chat if you have experienced flooding. We'd love to know what type of flooding you've experienced or what you're working with in your area. If you haven't experienced flooding in your area, have you heard of flooding nearby in your region or anywhere else? Okay, so some of you have seen it on the news, some of you have experienced it in other countries or in your community. Fantastic. So, what are the dangers of flooding? What is the environmental impact? Obviously, we know that flooding can be really dangerous for wildlife, just the amount of water. If animals can't swim, for example, it can be really dangerous. We know it can be detrimental to homes or cars and infrastructure. But what we're going to be talking about today is actually what we call stormwater runoff. And that's when rain falls from the sky, and typically what happens is it gets absorbed into the ground. Unfortunately, in most urban settings or in cities, there's nowhere for that water to be absorbed. So for example, in the photo you see here, in places like houses, on roads, sidewalks, driveways, that actually can't absorb any water, which means that water can't go down there. It has to run somewhere else. We call that runoff water, okay? And the dangers of runoff water are there's a few different. The first one is that it actually picks up all kinds of dirt and debris and toxins as it's being washed around your home or wherever it may be. So if on the street you find any litter, a big rainfall will actually wash all of that into the grate system and into our waters. And where that becomes an issue is that not only is the water not being filtered by not going through ground, because often through soil, grass, or plants, whatever it may be, water gets filtered and toxins get filtered out. So that step's not happening, but also that goes directly into our streams, rivers, and then our oceans. So anything that's on the ground is being washed away, which can be really, really dangerous for our oceans, for our atmosphere, and all. So we're going to be playing a game right now of Kahoot, and we're going to be looking at the permeability of different surfaces. And permeability is essentially whether or not water can penetrate into there, okay? And you might not be familiar with, and that's why we're going to play this game to get to know that. So Andriana is going to drop a link in the chat here to the Kahoot, and she's also going to drop the game pin in. If you're playing in your class, you can play as a class. The options are going to be 1, permeable, 2, semi-permeable, or 3, non-permeable. Okay, so permeable means that water can go through that surface. 2, semi-permeable would mean some of that water can go through the surface, but some of it gets run off. And non-permeable means that every water that hits there runs off. Nothing is being absorbed into the ground. Okay, so I'll give you about 1 minute to get logged in if you want to join as an individual or as a class. Again, if you're playing as a class, 1 is permeable, 2 is semi-permeable, and 3 is non-permeable. And you'll see those options pop up on the screen as multiple choice. Okay. And this is just a quick activity again to get to know some surfaces because we're going to be using this information when it comes to creating our permeability map. Okay, so I see lots of you are logging in. I'll give you a little bit more time to get that in. And we do have the friendly name generator on, so you will not be able to put in your actual name, but thankfully Kahoot has given us some very creative, fun names for you. Okay, I'll give you another couple of seconds and then I'm going to start the Kahoot. If you aren't able to join the Kahoot, that's okay. I want you to play along anyways, just in your own head or in your own classroom, okay? I'll give you about 10 more seconds. Okay, I'm seeing the numbers are still rising quite a bit. All right, in the interest of time, I'm gonna get started. Okay, so if you're not able to join, just play along with your fingers, or you're welcome to put that information in the chat, or if you're with your class, you can say that orally as well, okay? So let's get started. So we're playing permeable, semi-permeable, or non-permeable. So our first surface, a soccer field. Do you think a soccer field is permeable, semi-permeable, or non-permeable? So do you think that when rain falls on this surface, it is able to be absorbed? Okay, so the faster you answer, the more points you'll get in this activity. You have 2 seconds to answer. Awesome. So most of you did get that right. So grass or ground is typically permeable. So all the water that lands there should eventually be absorbed into the ground. That's why often there's much less puddles in fields than you'll find on gravel or concrete. Good. So there's a hint I already just gave you. Gravel, is gravel permeable, semi-permeable, or non-permeable? This might be a tricky one. 2 seconds, get your answers in. Awesome, so that is semi-permeable. Since gravel can't completely absorb that, some of it does actually run off of the gravel. So that we would consider semi-permeable. Trees. So for example, in a forest or where trees have been intentionally planted, can that be absorbed? Permeable, semi-permeable, or non-permeable? Awesome. So most of you did get that correct. Permeable. So just like grass, trees absorb that water, and trees actually use a lot of water for growth and all of that. So paving stones, permeable, semi-permeable, or non-permeable? And this photo is just one example of paving stones. There are many different types. So permeable again is the water can be absorbed in. Semi-permeable is some of the water is absorbed in, but some of it runs off. And non-permeable means none of that water is being absorbed. It's all running off, right? So most of you thought non-permeable. These are actually semi-permeable. Because there are gaps within the actual paving stones, there's space for water to actually be absorbed in there. But for the most part, they do run off. We would consider this semi-permeable since some of it does get absorbed. This game's tricky, isn't it? So a typical schoolyard. So look at the picture here of this schoolyard. So this is a pavement-based schoolyard. So what do you think? Do you think that water can be absorbed there? Some of it gets absorbed, some of it runs off, or do you think all of that water is running off? None of it is being absorbed into the ground. Awesome. So that is non-permeable. So some of you thought semi-permeable, but gravel and pavement, or sorry, just pavement or asphalt is non-permeable. So all the water will run off of that. Mulch. So mulch is essentially chopped up pieces of bark or tree that we put on top of gardens sometimes. So you can see it pictured here, little pieces of wood essentially. What do you think? Does mulch absorb water, absorb some of it, or absorb none of it? Awesome. So mulch is permeable, just like trees, grass, or anything that's typically found in nature. The sidewalk. So do you think sidewalks are permeable, semi-permeable, or non-permeable? Think about the last time it rained and you went for a walk. Were there puddles on the sidewalk? Awesome, we're starting to get the hang of this. Non-permeable. Sidewalks are typically made of concrete, which is not absorbent for water. And if this is all new to you, that's okay. A pebble garden. So these are little rocks. In this picture, they're put around a tree, but sometimes you can find them in just regular gardens. Sometimes they're decorative. What do you think? Do you think all water is being absorbed, some of it, or none of it in a pebble garden? Awesome. So that is semi-permeable. So some of that water can be absorbed, but some of it also runs off the rocks. Okay, I believe we have a few more questions. A parking lot. So this one I'm not going to explain too much because I'm expecting most of you to know. So a parking lot, what do you think? I've told you the answer of this one if you know what a parking lot is typically made of. Seeing lots of questions or answers come in. Awesome. So that is non-permeable. Most parking lots are made of asphalt, sometimes even concrete, which does not absorb any water, which means any water that falls onto it has to run somewhere else because it cannot be absorbed into the ground. 2 more questions. Lawn or grass? Permeable, semi-permeable, or non-permeable? Good. I'm seeing answers coming in nice and quick for this one. Okay, you have 3 seconds. Awesome. So grass is definitely permeable. Okay. Rain can get into grass and it is absorbed quite well. All right. And our last one, a baseball diamond. Do you think a baseball diamond is permeable, semi-permeable, or non-permeable? Awesome. So it is a permeable. You might think it's semi-permeable, but the gravel in baseball diamonds is actually so tiny that there's very, very little runoff water. Unlike pebble gardens, which have larger rocks, so more surface area to divert the water. So awesome. Thank you so much for playing. We're not going to bother looking at the prizes or who won because the idea was just to get to know what types of surfaces are permeable, semi-permeable, or non-permeable. So we should all have a really good idea about what these words mean and some examples of what surfaces fit into each category. We're going to be needing that for our permeability map. So it's really important that we all have a concrete understanding of this, okay? So now we're going to start by creating our maps. So what I'm going to get you to do is head over to Google Maps and I want you to find your school, okay? Adriana has just dropped a link to Google Maps in the chat there if you'd like. So you're welcome to follow that along. I'm going to be using this example with a former school that I've taught at, but I would love for you to use your actual school. So I'm going to zoom in to my school. And I'm going to ask that you put it on satellite view because we want to be able to make out what type of surfaces we're looking at. Okay, so you can change that just over here in the bottom left corner. So I'll give you a second to get that loaded up and find your school before I give any next instructions. Okay, so once you've found your school, we're going to be doing 2 things. The first thing is we're going to be looking at the permeable, semi-permeable, and non-permeable surfaces of our school. Now, depending on whether or not you're using Google Maps or you're using a physical map is going to determine kind of how we approach this. So I'll explain both. For me, I have a Google Maps account, so I'm going to be creating my map right within Google Maps. And in order to do that, you can actually go just on the left side here, there'll be a menu option. You can click on that, head down to your places, and then here I'm actually going to go to maps. And I'm going to just create a brand new map for this one, okay? I do already have an example made up, so I can show you that in a second. But for this one, I'm just going to create a brand new map. And I'm going to need to zoom all the way back into my school now. Okay. And again, I want to turn my base map to satellite. So if you're not creating this within Google Maps, you don't need to create a map. You can just look, you'll be able to use all the measurement tools within just regular Google Maps. But if you want to be able to save your map, and this educators is up to you how you want to run this, then you'll need to create a map right within Google Maps. So what I'm actually going to do now is I'm going to start plotting different things on my map. And I want to start with the non-permeable surfaces in my school. So I know my school quite well, but I'm going to start with my parking lot here because I know for a fact that parking lots are non-permeable surfaces, which means rainwater is not absorbed here. So anything that falls on this surface needs to run somewhere else. Okay, so what I'm going to do is I'm actually going to take this draw line feature here, and I'm just going to zoom in very slightly so that I can have a better view. Ooh, there we go. And if you're having any issues seeing this, please let me know, okay? So I'm going to add a line or shape. And I'm just going to start by drawing, and you can just click to add lines. And if you're making this on a physical map, you can just use your pen. It might even be a little bit easier. And I'm going to start by outlining all of my parking lot area. And this isn't going to be perfectly exact, but it'll be pretty accurate, okay? So I'm actually going to go all the way around, including the driveways. And I'm going to close off that section, and I'm going to label that parking lot, which is non-permeable. So for today, we're going to be using a couple of acronyms, okay? So as outlined in your handout here, permeable, I'll be referring to as P, semi-permeable, SP, and non-permeable as NP, just so that I don't have to write that out all the time. So back over to my map, I've now labeled my parking lot as non-permeable. And just to make this really easy to see, I'm going to choose a color, and I'm going to go with red, because red to me means no. So just like a stop sign, nothing is getting through. It has to stop here and find another way. So I'm actually going to color that red. Okay, and I'm going to go through and I'm going to do this for all the surfaces on my school grounds, and I'm going to label them each with different permeability. So for example, my parking lot was non-permeable, but I know that my yard here is permeable. So I'm going to start by clicking around here, and I actually have to go around here because there's a little bit of asphalt. So this map shows it pretty well, but I know my school pretty well. And I know that there's a little bit of asphalt there, so I know I'm going around that, okay? And I'm gonna do this whole section here, and later on, I'm gonna come back and I'm gonna have to subtract once I calculate my surface area, okay? I'm going here, that's gravel there, and I'm connecting again. So this is my yard, and it is permeable. Okay, because grass can absorb that water. It is permeable. I'm going to save that. I'm going to go here and I'm going to change my color to green because green means permeable. Okay. Now, if you zoom in a little bit, you can see that I have some playgrounds on my surface here. So I have two playgrounds that have gravel in there. They're more actually like little rock, larger rock pebbles. So I'm going to label those as semi-permeable. Okay, so I'm going to continue on, and I'm going to do this for all the parts of my school ground. Okay, and what you want to have at the end is a map that shows you all the permeable, semi-permeable, and non-permeable areas of your school, because we're going to be using this to calculate surface area. Okay, so this is, I'm going to label it playground, and that is semi-permeable. Okay, and I'm going to save that, and I'm going to label that one yellow. Now, you don't have to follow the same colors that I'm following. If you'd like to just use the acronyms, you're more than welcome to do that. If you'd like to change up the colors, you're welcome to do that as well. Okay, so we're going to go ahead and I want you to label all the sections of your school. Okay, and make sure you're trying to be as accurate as possible. So right here, I actually know that there's a bit of asphalt. So what I'm going to go do is I'm actually going to, on top of this piece, draw another shape to show that that's semi-permeable, okay? So if you have any questions, I'd love for you to put them in the chat, okay? Educators, if you want to gear this up, make sure that your students are following the exact shape. To gear down, you can use friendly shapes. So instead of going around all of these little pieces, I might just make this one big rectangle. So educators, you can decide how you want to gear that up or gear that down for your age range. okay? So I'll give you about 2 minutes to do that. Then I'm going to explain the surface area calculations and how we're going to do that. And then I'll give you some time to finish up both parts of that activity, okay? So I'll give you a second to just get this part started, and I'm going to keep working away on my my map here so that you can see. So somebody's asked again, how do you make the map? So if you would like to make it in Google Maps, what you can do is within Google Maps, okay? So you can draw things within Google Maps if you'd like, but if you want to be able to save your map within here, you're actually going to go to the menu section, go all the way down to your places here, okay? You're going to head over to your maps, and you're going to want to create a new map if this is something you want to save for reference later, okay? I'm going to head back over to the map that I'm working on. Oops. Now, we didn't talk about this, but what do you think the surface of your school would be? Do you think that's permeable, semi-permeable, or non-permeable? Think about if there's any rain being seeped through there, okay? So I'm going to go through and I'm going to start outlining that. So again, I'm using pretty exact measurements, and I'm going around all the little nooks and crannies. But again, update it for your age range and how you want to approach the surface area part of this activity, okay? Okay, so my school is non-permeable, unless you have a leak, in which case that's a problem. Okay, so I'm going to label that as red. So your map should start to come to life with very clear indication of the permeable, semi-permeable, and non-permeable surfaces on your school grounds. Okay, so now I'm just going to explain briefly how we're going to measure this information. So if you have a printout of your map, you're going to want to know a ratio. So what I'm going to get educators to do is to measure one part on your map, and then students, you can use a ratio, and here's a little bit of math involved, in order to translate that onto your physical map, okay? For those of you who are using Google Maps, we're going to use just straight Google Maps by using the right-click button on our mouse, okay? So this is where you're going to need your worksheet, because we're going to start calculating area. And this area is going to lead us to a lot more information about our flood risk at our school, okay? So here on this column, you want to put in the surface that you're measuring, okay? So I already have parking lot in here, so I'm just going to keep that going. So my first surface that I'm going to measure is parking lot. We should all know that area is length times width. We're going to be measuring using meters, okay? So heading back over to my map, I can actually right-click on my screen, and at the very bottom, you'll see there's a button that says measure distance. This is what I want, okay? So I'm going to drop my point. I'm going to start with, oh, I said I would start with my school, so I apologize. Let me start that again. Let me head over to here. So again, I'm going to right click. I'm going to clear that first measurement, and I'm going to start measuring again, okay? Now, educators, again, here's an opportunity to gear up and gear down, okay? Google Maps can automatically calculate the area for you. If this is something you would like your students to do, I would encourage you to have them actually write their calculations within their handouts, okay? So I'm going to show you just how to measure here, okay? So you can see I've drawn one line here, and it tells me my measurements. So it's written here both at the bottom, and I want the meters, not feet, okay? So we're looking in meters is what we're measuring. It also says it here. So I can do line by line. So if I wanted to section off my parking lot and figure out piece by piece the surface area, I could measure this bit. Then what I would do is I would clear the measurement by clicking right again, and then I would measure again from this point to this point here, for example, to get this square. And I would do that for every piece, okay? Now, if that's not what you want to do, an educator, some of your students might be beyond calculating surface area. And if that's the case, and that's not the intent for you in this workshop, then I encourage you to use Google Maps to figure out that information. So again, I can click, I'm going to clear my measurement, and I'm going to start a new one. So I'm going to measure the distance, and I'm going to go all the way around my parking lot as best as I can. And then what I can do is I can actually connect these back together, and it's automatically going to give me the area that I need. Okay, so the area of my parking lot is 4,178 meters squared. So I want to take that number, I'm just going to copy it on my computer, and I'm going to put it into my area here. And I've already labeled that on my map as non-permeable. So I can look right away and I can see it's red. So I'm just going to put an NP here. Okay. And you're going to go ahead and you're going to do that for all the surface areas of your school. So by the end, you should have a number of different sections here with your total surface area. Okay. So I'm going to give you a few minutes to do that, and then we'll start calculating our totals, and then we can start discussing what this information means and what we can do about it. Okay. So again, if you have any questions about how to create this map, how to use the measurement tool on Google Maps, how to calculate surface area, please let us know in the chat, and we can answer any of those questions for you. I see there's already quite a bit of stuff happening in the chat. So as you're going through, if there are no questions, I'll keep working away on my permeability map. So you're welcome to follow along and watch how I do it if you've forgotten. Again, if you have any questions, please put them in the chat. Okay, so you're looking for how to draw the line and how to measure area. So what you need to do is you actually need to right click using your mouse or your trackpad. So usually with trackpads, it's 2 clicks. With my mouse, it's a right click. Okay, this drop down menu is going to appear. I want to click measure distance. Okay, so from there, you're clicking where you want to start, measure distance, a dot will appear, and then you can just click along the perimeter of the surface that you're looking at. Okay, and then in order to calculate area, you just connect it back to the first dot, and to clear it, you can hit your right mouse again, clear measurement. Okay. If you're having issues with your view, you can change your map view here in the bottom left-hand corner, or if you're creating a map, it's in your base map here. So you can flip back and forth if you'd like. I recommend using satellite view, especially if you haven't been to your school in a number of months, as many of us haven't when we're working from home, and you maybe have forgotten where some things might be. This is a really great way to visually see exactly what type of surfaces you have at your school. Okay, so I'm going to keep working away here. Okay, so I'm going to continue labeling here. Okay, and don't forget that you're also adding your surface area measurements to your worksheet here. We're going to be moving on to part 2 briefly, okay? So again, if you have any questions or you want to let us know how your map is looking, we'd love to hear in the chat. Oh, iPads. That one's tricky. I'm actually not sure. I personally don't have an iPad handy to test that out. If anyone is able to get the measurement tool working on an iPad, please let us know so we can help you out there. If not, my friend, what I would suggest is that maybe you work with a partner. Maybe you can connect digitally with somebody who has access there. So if you want to color and label your map, you actually have to create a map. So that's where I went to the menu here, your places, maps, create a map. Okay, it'll bring you over to this screen here where then you can draw your lines and your shapes. You must connect the shapes back together in order to label them. So for example, if I was to do here is the outdoor classroom. If I was to label that here, just really quickly, I can connect them back together and then it will give me the option to label them. So this is the outdoor classroom and this is semi-permeable. Okay, so there's quite a bit of gravel and rocks, quite large rocks in this area. I'm going to label that. Once you're ready to change the color, if you're using Google Maps and you'd like to do that, you can just click on this paint can here and adjust as you see fit. Okay. So this will give us a really nice visual of the permeability of our surface area of our schools. Okay. So keep in mind as well, when you're calculating surface area, that if there is a piece of that surface area that is non-permeable, for example, you need to subtract that out. So for example, I told you that this asphalt here is all non-permeable, but right here, you might be able to see very small. This is actually a playground area that has gravel, which is semi-permeable. So instead of calculating my surface area by going around this shape, what I'm going to do is I'm going to calculate the surface area of the entire asphalt. Then I'm going to calculate the surface area of just this playground, and I'm going to subtract it from my total surface area of my playground. Okay. So again, I right click with my mouse, measure distance. And for those of you working without technology, if you would like, you can just calculate the percentage for right now. So you don't even need the actual measurements of your school grounds in order to calculate what percentage is non-permeable, semi-permeable, and permeable. I wonder how many times I've said those 3 words today. And as you can see here, this little piece here keeps getting in the way of my measurement. If I click on this, I'm going to lose all the lines I've already made. What you can do is you can also, typically with Google Maps, you can draw, you can drag, not, or maybe I'll just zoom in. Maybe it's only on this map that I can drag. Okay, well, just ensure that your full space is visible before you start with that measurement tool, or else you'll lose your work. There's a great question in the chat about whether or not fake grass is permeable. Well, I don't really know too much about fake grass if I'm being honest. I guess it would depend on what that's made out of. Okay, so you could probably have a look at it. And if you're at your school, maybe this is an activity you can do maybe on your recess, is actually pouring water on it and seeing if the water gets absorbed. For the most part, fake grass or fake turf is permeable. It is designed so that it can absorb water so that water doesn't pool on sports fields. I can't give that as a blanket statement because I'm not too sure what type of fake grass you're working with, but if it's any type of turf where water can be seeped in and it's outside, most likely it is permeable, or at the very least semi-permeable. So if you're really not sure, to err on the side of caution, you can label it as semi-permeable, or you can double check when you have a chance and then update your map afterwards. But that's a great question. So in order to color and label an area, you need to actually create a map within Google Maps, because that'll allow you to save it. Otherwise, every time you create a shape, it will disappear again. So again, I'll just reiterate how I went and did that. So I went to the menu function, your places, maps. I created a new map. Once you've created your new map, you'll be able to use this feature here, this draw line feature. So you'll add a line or shape. Whatever shape you pick, so for example, if I was to just do this little area here, once I close that off, which means I'm clicking on the same point that I started with to close my shape, it'll pop up with some information here. So I can go ahead and label that. I think this is also the driveway, part of the driveway. I can go ahead and save that, but I actually want to put in that this is non-permeable. So I want to make sure that I'm labeling things properly. I hit save, and then you can actually click on this paint can here. And I've chosen to label my non-permeable sections as red. So I've chosen red as my color, and then I can close that out. You can always come back and edit this information. I believe you can just hit this. Yep. So you can just hit that little, almost like a marker tool here, and you'll be able to edit that information. So if you're making a shape and it keeps deleting itself, it just means that you're not actually creating a map, you're just playing in regular Google Maps, so it won't be able to save any information. That's okay because we can track our information on our handout. So what I want you to do is grab that information and transfer it over to your handout. So the actual creating the map in colors is a great visual and super handy for us for a number of different reasons, for looking at the areas that maybe need more drainage, looking at where we want to keep things particularly clean. But what we really want is the surface area. So what I really want you to do is get this measurement part done. Okay, so in about 4 minutes, that's what I'm going to give you to finish up this chart here. We're going to move on to calculating the percentage, and I'm going to give you a little bit more information about what we can determine from this information. Okay, so I'll give you a few more minutes, about 4 more minutes, in order to calculate the surface area of these parts. So don't worry too much if the colors aren't working. While it's a great visual, it's not necessary for calculating any type of runoff. But I appreciate your questions coming in, so please keep putting those in the chat if you have them. If you have any comments or observations about your map, I'd love to see. Some of you may be surprised with how much red or non-permeable surfaces are actually at your school and how much of your surface isn't absorbing any water, which means it's all pooling and running off into local areas around. So again, in order to have your map view as satellite in regular Google Maps. So this is if you're not planning on saving your map, it's just in the bottom left here. You can flip between satellite and map. If you are creating a map here and you would like to save it, you just update your base map here. You can see I still have a little bit of work to do here. I haven't done the sidewalk. I missed a bit of my my driveway here. So I'm actually just going to adjust some of my measurements here. So I can actually click on these and adjust these points. Now that I've zoomed in and I can see I've missed some areas, I'm just going to zoom in and fix those to make my numbers a little bit more accurate. It doesn't need to be perfect. We're not looking for an exact number, but we want it to be as accurate as we can. Okay, so I've just found the surface area of my yard. So I'm going to bring that over into my chart here again. And again, that is permeable. But as I mentioned previously, I have some parts of asphalt within my actual yard. So I'm going to actually zoom in on those parts, take the surface area of that and subtract it from my total surface area. This part here is gravel, and you might know why this part is gravel. This is actually a hill, which might give you a hint. So I'm going to take that number, and I'm actually going to, so this yard is minus that. Okay. Okay, and that's permeable. Okay, so I'm going to give you about 1 more minute to continue working through the surface area worksheet. So hopefully you're able to get most parts of your school down in there. If not, that's okay. You'll have some time at the end to come back to it. But I do want to be able to explain the rest of the activity for everyone. So I'll give you about 1 more minute. So again, to clear measurements, I can just right click and hit clear measurement again. Okay, so I'm just going to explain the next part of the activity. If you're not ready to move on yet, that's okay. I want you to stop right now and listen anyways. That way later on, when you are ready to move on, you know what to do, okay? So once you finish calculating the surface area of all the sections of your school grounds, we want to know our permeability percentages, okay? So you want to put in your total area. So what you're going to do is you're going to come back up to your first table, and you're going to add up all of the non-permeable sections of your school. So you want a total surface area of non-permeable surfaces. Unfortunately for me, I did not do a very good job of finishing up my map, so I only have one non-permeable surface to put in. But if I had more, I would be able to add those all together, and that's the number we want to put in here. Okay, so you want to do that for non-permeable, semi-permeable, and permeable. Then you want to get a total of how much surface area you're looking at in total. So you're going to add all of those up together to get your surface area total. Okay. I'll give you 1 second if you wanted to do that, if you're ready for that step before I explain the percentages. Okay, so based on the information in this table, we'll be able to calculate our percentages. So in order to do that, we're just going to take the total area of each section and divide it by our total study area. Okay, so I would take my total non-permeable area that I calculated by adding all the surface area of the non-permeable surfaces together. I'm going to take that and I'm going to divide it by the surface area of my total school grounds, so everything included. Okay, and that's going to give me a percentage. Sorry, multiply by 100, and that will give you a percentage. Okay. And from there, we can determine what type of runoff our school grounds have. And our goal is always to have a very low runoff. Okay, so a 100% permeable surface is fantastic. The more semi-permeable and non-permeable surfaces we add in, make it so that less rain is being absorbed into the ground, which then kind of brings up all the issues that we talked about with rainwater runoff, bringing different toxins, garbage into our water streams. Did the percentage of your school surprise you? Maybe you can go out and check, but do you have any, for example, street grates in your parking lot? Is there anywhere for water to be diverted to, or where is that water intended to go? You might already have some structure in place or infrastructure to divert water out of that area. So have a look there. We do on our Flood Ed page, which is where this activity is from. We do have a full repertoire of photos. So if you're looking for flooding infrastructure, which is just different things that are put in place in order to become more resilient to flooding or avoid flooding, you can have a look at this photo gallery here to get to know the names and whether or not you do have any flooding infrastructure. So for example, if you have a big field of asphalt, you might have a culvert nearby where water can be drained to. Or potentially you might have some runoff from your school being led somewhere by a swale. Do you have any downspouts at your school? Where does that water end up? So this is a great tool as well. Also great if you're looking in your community trying to find where all of your flooding infrastructure is. Oftentimes, this infrastructure was put in long time ago when streets and roads and schools were first built and hasn't been updated since. That's a huge problem because climate change is changing our climate, which means that rain is not only becoming more frequent, but it's becoming more extreme, which means that when it rains, it pours. And that causes issues for flooding because that doesn't allow time for the water to, for example, go down grates or be absorbed into the ground, which means we have pooling or ponding occur. And as we know, that's not great either. So there are a lot of different factors there. And Andriana has just dropped a link in the chat to this flooded photo gallery if you'd like. Now, Before we end off, I'd like to give you some next steps on where you can take this information, because many of you may not have had the opportunity to finish up your flood map. So once you've finished your flood map, what we use this for is calculating our runoff footprint, okay? So within our flood ed program, we actually have a runoff footprint calculator. And Andriana is going to drop a link up to this in the chat as well if you want to check it out, where we can actually put in the millimeters of rainfall. So for example, here in Kitchener-Waterloo, I believe we're expecting rain sometime later this week. Unfortunately, we got snow last night, but I know the rain is coming and I'm hopeful that it will warm up. We can take how much rain is going to be falling. For example, maybe it's 5 millimeters. Then we can input the total non-permeable surface area of our school grounds here. So again, we calculated that information on our second sheet here. So this is the information I'm looking for. Right? Then you can put in your semi-permeable surface area and you can calculate, and it's going to tell you exactly how many liters of water are being run off of your surface area. Then you can start to make plans on how you can adjust your school grounds in order to be more eco-friendly and more resilient to flooding. So within our flood ed program, we have some ideas all ready for you. So within our challenge, you can go to take action. And here's where we've identified a number of activities that can help you become more resilient to flooding if your school has a high non-permeability percentage, okay? So for example, installing rain barrels to capture the rain that falls off your school. So as we know, schools obviously are non-permeable, so all of that water needs to go somewhere. We may as well collect it and use it, for example, to water a garden. You could plant a tree. That actually helps filter water to be put back into our streams. Or a rain garden does the exact same thing. This activity here happens to be one of my favorite, is the idea of adopting a drain in your community. So we know that one of the biggest issues with stormwater runoff is the toxins and garbage that are picked up along the way and end up going down those grates, which end up in our streams and eventually in our ocean. And garbage and toxins in the ocean is a really big issue. But one thing that we can do is we can actually adopt a local drain and commit to keeping that space clean, so that not only are we keeping that grate free of any debris, which means that rain can actually be drained out there and it's not being blocked by any garbage, but we're also stopping garbage and toxins from being put into our water streams. We also have a flood protect your home activity. So if you're working from home or you want to connect this learning to your home, you can actually do an entire scavenger hunt of your home to determine its flood risk. So this is where you go around and you're looking at any areas of weakness. So maybe your basement doesn't have proper infrastructure, or you need some more downspouts off of your house. This activity will help you identify those and create a plan of action to make your home more resilient to flooding. Now, I'm going to bring you to the last piece before I leave you, is the Flood Ed Challenge. So now I've just given you all the information that you need in order to create a flood plan for your school. So you already know the problem areas, the non-permeable surfaces of your school. We have an idea of what some of the issues with runoff water might be. You have some ideas on how you can take action to be resilient to flooding. All you need to do now is put that into action and take part in our challenge. So you can register for this challenge. It's completely free. All of the learning materials are completely free to access as well. We have a number of different activities within here, including the permeability map, the flood mapping that we just did today. So you can use all of this to determine your runoff footprint and create a plan for your school. Best part is you actually have a chance to win money for this. Okay, so first place prize is $1,000, second place is $500, and third place is $250. And that money can be used towards making your school more resilient to flooding. So maybe you want to invest in some rain barrels, or maybe you want to invest in actually making a rain garden. This money can help you do that. So what we're asking you to do in the challenge is to do exactly what we've done today, but determine, what does that mean for your school? What does that mean for the flood risk? Are you at high flood risk? Are you not? What can you do to increase your resiliency? Okay, so I want to thank you all so much for coming today. I hope that you have a better idea of the flood risk of your school, of the permeability and stormwater runoff. I hope that you're excited to become resilient to flooding, and I hope that you have at least a couple of ideas of how you can move forward and become more resilient to flooding. If you have any questions, please feel free to put them in the chat. We'll be hanging around for another few minutes. I will be sending a follow-up email tomorrow with a recording of this session in case you missed anything, some additional information about the challenge. But Andriana did just drop a link in there in the chat to it. So if you want to go ahead and register now, it only takes a second. I will, by registering, you also do get all kinds of additional information and resources as well. So I encourage you to do so, even if you think it's not feasible to put any of these plans into action this year. Creating a plan is always the first step, and we'd love to see that. If you've created a map today and you've managed to finish it, or you've finished filling out your handout, we'd love to see any results that you have or any conclusions that you've drawn about the flood risk of your school. So feel free to email those to me. Again, you can reply to my email that I send tomorrow, or all of you do already have my contact information. So thanks again so much for coming. I'm going to stop the recording now.